Hello everyone, this is a new video on quantum mechanics numerical sessions. This one will be a bit different here. We'll be discussing about one of the important topics that come in GATE. Okay, this is spin angular momentum. This is a very important topic. A lot of questions come from this in both GATE, NET, JEST. Okay, and also in interviews. Very important topic for interviews, and you'll be asked a lot of questions based on this topic. Okay, so spin angular momentum. So existence of spin, how a spin came into picture. Existence of spin actually was confirmed by was confirmed experimentally by Stern and Galan. Okay, okay. So so what happened? This is your sodium. Sorry, silver. This was taken. This is the north pole. This is south pole. Okay, and ray passed through it. So one part was spin up. It was observed that one part was spin up, and the other part was spin down. Okay, and this was your screen, right? And this occurred like it was carried out in homogeneous static magnetic field, right? So so here what happens is electron beam. This is an electron beam. Okay, an electron beam neither behaves classical nor Schrodinger according to Schrodinger wave theory. Okay, instead, it what happens? It splits into two different components. Okay, it splits into two different components. That's it. Okay, so from which part the questions actually come? We don't need to go much deep into this all this. Okay, because questions will be won't be theoretical. Questions will be really mathematical, like numerical based. So according to general theories of like angular momentum, so Sx commutator bracket of Sx Sy will be what? IH cut Sz, the things. These are the things that are important. Okay. So for example, Sx Sz, that will be what? That will be a minus IH cut Sy, isn't it? Because the order should be X, Y, Z. If we are commutating x and y, we will get z. If we are commutating yz, we are getting x. But if we are commutating x and z, we will get minus y, isn't it? So Sx Sy commutator is IH cut Sz. Sx Sz commutator is minus IH cut Sy. Suppose S square Sz. How much it will be? S square Sz. It will be what? It will be 0. That means what? S square and Sz commute with each other. Okay? They commute. Alright? Okay, so now what is it? Now S square, if I act upon SMS, okay, if S is a spin, for example, S is 1, so what are the MS values? It will have minus 1, 0, 1, isn't it? If S is 2, its MS values will be minus 2, minus 1, 0, 1, 2. Alright. So S square S, if S square is acting on the S MS, so eigenvalue will be S whole into S plus 1, H cut square, and this one will remain as it is. Okay, for example, SZ is acting on it. Okay, SZ is acting on it. SZ actually acts on what? This one. Okay, so it will wave. Sorry, this one may be MS. Sorry, MS is equal to MS H cut SMS. Okay, these are very two important formulas. Okay, now ladder operators. Ladder operators means, what do you mean by ladder operators? Okay, what do you mean by ladder operators? Just a second. Yeah. What do you mean ladder operators here? That means something that will increase the value. See, S plus. S plus is a ladder operator. What it will do, for example, S plus S ms. Okay, what will it do? It will increase the value of ms by 1. Okay, but its eigenvalue will be h cut. When there is plus here, it will be S minus ms, S plus ms plus 1. Okay, S ms plus 1. All right, yeah. Or if S minus sms is there, then h cut S plus ms, S minus ms plus 1, S ms minus 1. It is decreasing one value, it is increasing one value. Okay, this is your, it is increasing the value of ms, this one is decreasing the value of ms. This is your what? This is your eigenvalue of s plus h cut whole into root over of s minus ms, s plus ms plus 1, s plus ms, s minus ms plus 1. All right, next is what? Next is s plus, we can write it as sx plus isy. Hmm. And s minus, we can write it as sx minus is. All right, yeah. Now what is the expectation value of sx square? Sx square expectation value, sy square expectation value will be same. That will be h cut square by 2 s whole into s plus 1 minus ms square. Okay, now what are the other things? Expectation value sz square will be how much? ms square h cut square, simple. Okay, now expectation value of s plus s minus will be s square minus sz square plus h cut sj, right? This is what it is. Okay, yeah. Now is spin half and the Pauli matrices. Spin half and the Pauli matrices. Pauli matrices. Okay. So for example, spin is half. So what are his ms values? Half minus half. Okay. So I can write it the like the eigenvectors s ms. I can write it as half half. That is this one and this one, and half minus half, isn't it? So this is a what? This is spin up. This is what? This is spin down. Okay. This is spin up. This is spin down. So now we will apply all the formulas that we have studied so far. Okay. Now tell me eigenvalues. We will calculate eigenvalues of s square and sj. So s square half half will be how much? See, this is s square s ms. That is what h cut square. Okay, there won't be root over because this is s square, right? So h cut square. Sorry, s whole into s plus 1, h cut square simply s ms. This one won't be changed. So just put it here, half whole into half plus 1 because this is your s, this is your ms. Half whole into half plus 1, h cut square, half half. So this one will become half into 3 by, that is 3 by 4 h cut square, half half. Okay, all right. Now sz, I will apply sz here, half to half half. So we know sz eigenvalue is what? Simply that ms h cut. So ms is this one, half h cut, half half. Okay, this is all right. H cut by 2. If this is minus, this is minus. All right. Yeah. Okay. Okay. For example, is square half minus half. So even if that is half whole into half plus 1, because this is only s now, this is s whole into s plus 1. So this is not deterred by this, like not affected by this one. So half minus half. The eigenvalue will remain same, 3 by 4 h, sorry, h cut square, I'm missing. 3 by 4 h cut square, half minus half. Alright? Yeah. So now Now what? So this half half we write it as spin up. We can write it also like this. Half minus half is spin down. So we can write it like, okay. So I can do this also 3 by 4 h squared square. No problem. Alright. So how do I represent spin? See, in vector atomic model, how do I represent? This is your sxy, this is your sz. Okay, sz values. So there are s value has like 1 for a half, ms is what? Minus half and minus half. Okay, and h cut by 2 minus h cut by 2. Right? So this will be your h cut by 2. This is a minus h cut by 2. Okay, if I draw a semicircle, is it? It's actually what? It's actually this vector. This vector. Okay, this one. So after that, I will join this. Okay, it will do the precise motion, precision. It will do. Okay, so this is your theta. This sorry, this one only. Okay, this is s vector. This is s vector. Okay, so theta here will be cos inverse ms by but s1 into s plus 1. Okay, right? Yeah, that is this is your what representation of spin. I'm telling just in perspective of exam. Okay, get on it. Like if we can go deep, we can go deep, but that won't help us in exam that much. Like we need to know all these things, right? Unnecessarily, we should not go that much deep. That will be taught separately in MSc. Okay. Yeah. So next is what matrix representation of spin. Matrix representation of spin. Matrix representation of spin. So we know. So yeah, see, remember this. S plus would be written as h cut 0 1 0 0. S minus will be written as h cut 0 0 1 0. Okay, and your s square is how much? 3h cut square by 4 1 0 0 1. And your sx is how much? H cut by 2 1 0 0 1. Sy is what? H cut by 2 0 minus I 0. And your sz is h cut by 2 0 sorry 1 0 0 minus 1. Okay, got it? Yeah, yeah. So how you can ask me how did I calculate sx sy? Because see, we are given s plus s minus, so we know sx is equal to what? Half s plus s minus. Sy is equal to what? 1 by 2i s plus minus s plus. From that we calculated these two. Alright. So Pauli matrices is what? Pauli matrices. Pauli spin matrices. Pauli spin matrices is S is equal to h cut by 2 sigma. This sigma is your Pauli matrix. Okay. So Sx will be what? H cut by 2 sigma x, which is equal to h cut by 2. We have written in the previous slide 1001. So sigma x is how much? 100. Now Sy is h cut by 2 sigma y, which is equal to h cut by 2 in the previous slide 0 minus I 0. So from that sigma y can be written what? 0 minus I 0. Now Sz is equal to h cut by 2 sigma z. So h cut by 2 is equal to h cut by 2 I 100 minus 1. That from that we can write sigma z how much? 100 minus 1. So if I write all this together, sigma x is equal to 0 1 1 0, sigma y is equal to 0 minus I 0, and sigma z is equal to 100 minus 1. Okay, these are what? These are the Pauli matrices. Pauli spin matrices. Alright, is it clear till now? Okay. If there is any doubt, you can ask me in the comment section, no problem. This should be clear. Okay, this is Pauli matrices. Alright. Now we will study the properties of Pauli matrices. Properties of Pauli matrices. Properties of Pauli matrices. So properties, what are the properties? See, trace of sigma is 0. You can see 1 0 0 minus 1. This is 0. Trace is 0. 0 1 1 0. There is no trace. 0 minus I 0. There is no trace. 0 trace. Okay. Determinant of any polymatrix is how much? Minus 1. You can see minus 1, minus 1, minus 1. Okay. Sigma x square is equal to sigma y square is equal to sigma z square will always be I. Okay. If you multiply it again and again, it will be I. This is your unit like 1 0 0 1 unit matrix. Now IV sigma x into sigma y is equal to I sigma z. Sigma y into sigma z is equal to I sigma x. Sigma z into sigma y, how much? Sigma x, I sigma y, isn't it? It's very clear. Okay. Now sigma x the sigma y into sigma z will be how much? I into unit unit matrix. Okay. Alright. Now sx square is equal to sy square is equal to sj square will be how much? H cut square by 4. It won't be I. Okay. Another one, sigma x sigma y plus sigma y sigma z sigma x is equal to 0. How? Because sigma x sigma y is how much? It is I sigma z. Sigma y sigma x is how much? Minus I sigma z. Okay. Sigma square sigma. This will be 0. Okay. Yeah. Sigma x or sigma y. Commutator bracket 2y sigma z. A very important formula that usually comes in exams, e to the power I alpha sigma z n cap is equal to I cos alpha plus I sigma j dot n cap sin. This one is very important. Okay. Eigenvalues of Pauli matrices. Plus or minus 1. Okay. Now A dot sigma B dot sigma is equal to 2i A cross B dot A dot sigma and B dot sigma commutator is 2i A cross B dot sigma. Okay. Properties of spin matrices. So first one is Sx, Sy, Hz expectation value is I h cut cube by 8. Sx is equal to expectation value Sx is equal to expectation value Sy is equal to 0. Okay. But expectation value sx square is equal to expectation value sy square is equal to expectation value sz square is always h cut square by. You must be worried like how to remember all these things. See, you will automatically be remembering all these things. Now s square is how much? Tell me. Wait. S is what? S vector is s1. For example, there are two spin vectors s1, s2, and the resultant is s. Okay. So s vector is s1 vector plus s2 vector. So s square is how much? S1 square plus s2 square plus 2 s1 dot s2, right? Okay. Now this becomes 2 s1 s2 is equal to how much? S square minus s1 square minus s2 square. Now s1 dot s2 is equal to how much? S square minus s1 square minus s2 square whole divided by 2, which is equal to s whole into s plus 1 minus s1 whole into s1 plus 1 minus s2 whole into s2 plus 1 whole divided by 2, and there will be a h cut square. Did you get it? Okay. Yeah. Okay. Now for ground state, S will be 0. Okay. And for triplets, this is called singlet state. Why singlet? Because multiplicity is 2s plus 1. So if I put 2 into 0 plus 1, that is your 0 1. So 1 means singlet. Okay. Again, for triplet state, for triplet state, s is equal to 1. How? Because m, if I put s is equal to 1, 2 into 1 plus 1, that is 3. 3 means 3 states is triplet state. Okay, this is your triplet state. Alright. Now, how do I do this? Sx1, sy2. How do I multiply this? See, h cut square by 4. What is sx? This is 0, 1, 1, 0 cross. Okay, this is tensor product. Okay, tensor product. So how the tensor product works? It simply works individually. See, this one will be multiplied with the whole thing. This 0 will be multiplied with the whole thing, become 0, 0, 0, 0. Now this 1 will be multiplied with this thing. So 1 0 is 0, 1 minus I is minus I, 1 I is I, 1 0 is 0. Okay. Now this one will be multiplied with this one and placed in that place. Okay. 1 into 0 is 0, 1 into minus I is minus I, 1 into I is I, 1 into 0 is 0. Now this 0 will be multiplied with again whole thing. So 0 multiply will be giving me 0. Okay. So this is called your tensor product. Alright. This is giving me what? Tensor product. Alright. Is it clear? Is it clear? Now we'll do spin eigenvalues and eigenvalues and eigenfunction of SZ. Eigenfunction of SZ. Okay, so SZ is equal to what? H cut by 2, 1 0 0 minus 1. We know it, right? So here eigenvalues are h cut by 2 minus h cut by 2, right? So I can write it as what? I can write it as it's an eigenstate of z is equal to 1 0. Another eigenstate, this one, this. Another eigenstate, okay, just a second. Hello. हाँ मैम. Good evening मैम. କେତେବେଳେ ମ୍ୟାମ୍? ସକାଳେ ସକାଳେ ଟିକେ ପସିବଲ୍ ହେବନି. ହ୍ୟାଲୋ. ତାହେଲେ ମ୍ୟାମ୍ କେତେବେଳେ? ठीक है श्योर, ठीक है, थैंक यू। सॉक्कर मैम नाटी सॉक्कर होगा, थैंक यू। Okay, so this one is what? This one is 0 1 z. Okay, so psi is equal to a 1 0 is b 0 1. Okay, so this is 1 0. This one 0 1 is right. Yeah. Now spin eigenvalues. Sx is equal to h cut by 2. We know 0 1 1 0, right? So lambda is equal to h cut by 2 minus h cut by 2. So here your eigenstate is what? 1 by root 2 1 1, and for this one 1 by root 2 1. Okay, so 1 by root 2, let's set so minus z. Okay, now for sy also calculate sy minus I h cut by 2 minus h cut by 2 and then to 1 I and then to 1 minus. Okay, so minus layer 2 plus. Okay, yeah. So these are the eigenvalues, eigenvector, spin, and everything related to spin. Okay, spin angular momentum. All right. Yeah. So yeah, based on this, we will do numericals in the next session. All right. So these are the theory. So complete the theory. Try to remember everything, and yeah, practice. More you practice, the more you'll be able to solve this kind of questions. All right. Yeah. Thank you very much.